Okay, so sticking with the Python thing here, I went ahead and did the class notation, created an object for this. And really, this is what would be needed for any game engine. So the plan for doing it in Unity was just to do this exact same logic here in C Sharp. But everything we've been looking at so far is in Python, so I thought it might make more sense for the tutorials to see it in Python. But this same logic in C Sharp syntax is what would be needed in order to do this in Unity uh, to bring our controller in. So just some object representing the controller, and the constructor basically just calls that find com port method we looked at the other day. I went ahead and combined them all in here as part of the initialization. So just get a list of available ports, and then walk through from 1 to 256. But really, anything based off a microcontroller should be between 3 and 12 because of the old assignments when there was actually a physical com serial port. Uh, Microcontrollers were assigned values between 3 and 12, but since it's gone virtual, it could be one of the other ones. So just check loop 1 to 256. That's pretty quick. And check each one, just open and close. And if that much works, then there is a COM port there. So that builds up the list. Then walk through each one, connect, and here in Python, we have to wait for it to reboot, but in C Sharp, you wouldn't need the reboot time. As long as it's powered up, it's fine in C Sharp. So you wouldn't need the reboot time there, but here in Python, we have to wait for it to reboot, send our keyword, and then just look to see if it got the right response. And remember to set both a read and a write timeout on those, because if there's, like, say, a Bluetooth device that regularly connects to your computer, the COM port will show up, but if the Bluetooth device is turned off, it'll try to write to that COM port and just get hung up on that and essentially enter an infinite loop. It'll just get stuck and you'll have to manually crash the program. But that's basically all it does in the initialization or the constructor in C Sharp. And if it finds the COM port and connects, it returns that. So then any instance of this, you just need to run the constructor and check and see if it's none or not. If that COM port is none or null or whatever the syntax for that language needs to be for nothing being there, then it didn't. The controller didn't connect, so fall back to like the keyboard commands or something. But if it connected, then that's all. Then it can just call these methods. So a bunch of getters, which are just like we've seen. Just write the keyword command, which in C Sharp you do not have to manually convert it to a binary string. And there's a write line method, so you could use write line and not have to include the line breaks. But whatever syntax is appropriate for that language, and just have a getter for every control on the controller. And that's basically all the object needs to do. And no matter what type of game engine you're working in, you could just create a class with that same logic. So the constructor just calls this method that checks all available ports, figures out which one the controller is connected to, and then a whole bunch of getter methods for each of the buttons. And then that would work with any game engine. So for us here, and then I put together a test one. You can see the results from that. It just loops through 100 times with a half-second delay each time, and that was enough to go through and push all the buttons and move all the joysticks and flip the switches and turn the knobs and slide the slider. And I was able to tell that all of it is coming through, so I'll delete that test one. But this logic would be the same no matter what game engine you're working with. I just decided to stick with Python, and I'm going to be doing some PyGame and Panda 3D game stuff on a tutorial soon, and I think that's what I'm going to do my next few educational games in, and do a tutorial playlist going over scripting games in Python. So now that we have our controller object, we can bring it into our test game and move our sprites around with the controller just to test and confirm that it works. Oh, and while it will only be a split second on the video after the editing, I'm also going to go ahead and add in the oxygen comments like we saw. Find the COM port the controller is connected to, and then at return will either be a serial dot serial communication object, or none. So I'll go ahead and do all the oxygen comments. We've seen that a few times, just to not get behind on that. But there's no need to watch me type that. We've seen that a few times. If we're in Python, two pound signs, two comment symbols to indicate oxygen. This is something to put in the website, and then like @param and @return are the main keywords we'll use. And then we can include some HTML code if we need it. We've seen that a few times, so I'm going to pause the video, and when it comes back, we'll be adding this into the actual game. Okay, so we've got the comments added in there and ready to give this a first test. We'll come back and actually make a PyGame joystick object later. But for now, just making sure all the pieces work. I think the simplest way to check it is just call the methods from that object and run through that way. So I'm going to set up some global variables. So like player start x equals some spot on the screen. Player start y equals some other spot on the screen. And we can start with those variables. Player start x, player start y. So he's going to start there, and basically we'll just check to see if the joystick moves and adjust those accordingly. And I'll do that in a little function here. Define player control. I don't think we need to pass anything in for it. And basically all this is going to do is adjust how far it moves. So I'm going to set up a speed variable. I'm not sure. I'm just going to pick a random starting point here. We'll see how this does at 60 frames per second. Then adjust that speed as needed, because our controller, if we go over here, if we ask for, say, the x-axis, it's returning the floating point number, a percentage. So we'll multiply that by the speed and just increase our x and y positions by that much. So player, actually we don't need start, do we? Start's a little redundant there. Let me get rid of the start. And just make that the player x and y. Don't need to, I was thinking be able to jump back to that position, but for a quick test, there's no need to jump back to it. So the player x position is going to increment by our controller object, which we need to initialize, get x. So the x percentage multiplied by the speed, and that'll give us the movement. So we'll also need our controller object And that's going to take the longest time to initialize the way it's set up right now. So I want to do that before initializing the PyGame window. So let's see, we'll need to import basic control unit from basic control unit, import everything, and then the very first thing is I'm going to initialize that. So controller equals a basic control unit. And that should give us the controller, and then we'll be able to get the X and the Y and move our player accordingly. Player Y plus equals controller.getY times speed. So let's see if this works. Give it a test. I'll come over here. Looks like I'm in the right folder already. So Python test1.py. We run this. It'll start by connecting the controller. So it's checking the ports, which I could probably speed up that time a little. Have to sit down and just trial and error and find the quickest trial. There we are. So everything loaded up. Oh, did forget to call that method that moves stuff. So let's close this and give that another try. And before calling that player position, call player control to see if the player position moves or not. So save that, give this another test run. The general process for debugging. Run it, fix the stuff we forgot to include, run it again. Get connected. Uh-oh. Player X referenced before assignment. So, oh, because that's local, I need to set the global one. Global player X, global player Y. Try that again. The standard process for debugging. And once it loads up, hopefully it won't crash this time. Oh. Did I spell something incorrectly? Controller is not defined. Oh, yep, I sure did. Controller. So give it another try. Scroll down a little. And I definitely need to adjust the time there. And I was hoping this would be under 7 minutes. And it looks like we just passed 6 minutes. Oh, so very, very slowly. So that speed is definitely too slow. So let's go back over here, make a couple adjustments. I was thinking it might need to be a smaller number. Let's try a big number like 5. Get it moving. And our Y, the controller we went with pushing with the normal math class XY axis where up is positive, but on a screen down is positive, so we probably want to do subtraction assignment instead of addition assignment there. Give this one more run. And we can see that gets our player moving around the screen okay. Put some animations in there and it would probably look a whole lot better. But that indicates the controller is working correctly. That's all we needed to check at this point. So we know that works now. And I still haven't fixed that -4 thing, so probably do the same thing I did on the other script and just put a little buffer area, make sure it's bigger than, say, 7 before it moves. And mess around with the speeds, but 60 frames per second seems to be moving pretty smoothly here. At least what I'm watching, the video I believe is being recorded at less than 60 frames per second, so it might not look quite as smooth on the video. But that is enough to indicate the controller is working as expected. So the key point is need an object like this in any of the game engines. So I'll probably go ahead and make this same object in C++ and C# and Java, and that's the first one springing to my mind. But that would cover most of our game engines, and just go ahead and set up the drivers so that these commands are available in any game, any of our major game engines, and then we can just use these values to control the character. But it appears to be working, so I guess now I'll get into some cleanup, mess around, do different things, try and see what works. And once I get some of that refined, there is another step where we can use a PyGame joystick object and then just add that into our regular event listing. But we have to update a whole lot of drivers to do that, so we'll come back and do that later. So for now, just some cleanup time. I'll get to that and come back in and look at how the cleanup's coming in later videos. So I addressed those two obvious things from that first test. I set the condition like we saw earlier. If you haven't seen this notation before, this is a one-line way of writing an if-else structure. So we look at this condition, and if it's true, do this. If it's false, do this. So the notation is in parentheses. We do the false return, the true return, and then in square brackets, put the condition. Just in case you haven't seen that notation, that's if the absolute value of the x, which is just reading the line, is more than 7, then return that divided by 100 to get a percentage. Otherwise, just return 0. And a graceful disconnect. So just close the COM port if nothing else. So over here, before quitting the game, then go ahead and do controller.close to actually disconnect. So let's give this a run. And once again, it'll scan through the available ports. Which I really need to sit down and just do some trial and error to figure out what the minimum speed for that is. And now we don't have that -4 problem anymore. Character moves, and we just ease into barely moving very slowly, or move quicker, and get a good bit of control over the character movement. More than we would have with, say, the A, S, D, and W keys, which are only on or off. We can do those subtle easing into the movements. And when we're done, close, it should gracefully disconnect. Oh, whoops. I forgot the class notation, so I need to say that applies to itself. But one little shutdown error shouldn't be much of a problem. And yeah, now it's just a whole lot of the cleaning up and testing and running all the tests on making sure all the electronics works with Arlo protocol here. And once we're certain everything works like it should, then we can come back and set up another driver that would follow the standard just import the game engine type joysticks. So like in PyGame joystick, which fits right in our event list. But we want to make sure all the electronics work before we go writing that, because that is a lot harder to follow and a little harder to debug. So I like to debug stuff in an easy way, and then if a complicated standard is needed, do the complicated standard after we know everything works. But for checking that everything works, still a whole bunch of cleanup. So I'll be back in a couple days to run through the cleanup that has occurred and testing the controller.